Alright, so let's take a look at the second part of the problem set. Use the regression equation you wrote in 2a to predict the number of calories in a fast food item that contains 70 grams of fat, or explain why it would be inappropriate to do so. And question 4 is just like it, only it asks about 10 grams of fat. So let's rewrite our regression equation. So our regression equation was calories is equal to 163.2 plus 12.9 times fat. And so to use the regression equation, you simply replace fat with the numbers that you're given. In the first one, we're given 70 grams, and in the second one, we're given 10 grams, but we have to be careful. It asks us to do it if it was appropriate, but not to do if it was inappropriate, and explain why. So let's take a look at what makes it inappropriate to use the regression equation and what makes it appropriate. So we have to go back to our regression analysis. So let's go back to the analysis we did. Now there's several ways you can do this. If you're a picture person, you can look at your picture. What you need to do is you need to see the scope of your data, meaning where did the data start and where did it stop in the x-axis. So you can see along the x-axis it goes very close to 0, and on the y-axis it goes past 80, but not that far past. So what that means is anything between x, say around 5-ish, and y, say around 90-ish, any of those numbers would be okay to plug in. Now for those who don't like the ambiguity of that, looking at a picture, you could also do it by looking at the lowest number and the highest number in your data set. Now the way you would do that is you would come here to Stat, Summary Stats, just like we've been doing in Chapter 3, and we want the summary stats of the fat column. We want to learn more about the fat column. And what we want to know about the fat column, and again, if you come here and if you just went to compute, it would give you all of these items, which would be fine. But if you don't like being distracted, you can simply pick out the ones you want. So let's deselect all of these. And what we want to know is what's the minimum number, the smallest number, and what's the maximum number, the largest x value in the data set. All right, so if we go to compute, we can see that this smallest item, or the smallest x value, is 3.5, and the largest one was 87. So what that means is that any number within the scope of that data between 3.5 and 87 would be okay to use the regression equation for. You can go out a little to the right and a little to the left, but not very far. All right, so let's go back to our problem set, and let's maybe try to draw a picture of what we just talked about. So what we talked about was looking at our data, and when we looked at our data, the lowest number was 3.5, and the highest number was 87. So that means that in here, any number in here, it's okay to use the regression equation. It's okay to go a little bit to the right and a little bit to the left, but not very far. Okay, so what numbers were we given? In this problem, we were asked about, in the first one, 70. So 70 is within the scope of the data, and we were asked about 10. 10 is also within the scope of the data. So it's okay to do both problem number 3 and both problem number 4. Here's an example of something where it would not be okay. What if we asked instead about 70, we asked about 700? Now notice 700 is far beyond 87. So if it was 700, we could not do this problem. But since we asked about 70, the answer is yes, we can. And how do we do that? We just plug in 70 for fat. So to answer question number 3, we simply take 163.2 plus 12.9 times 70. And we would do that on a calculator, and if we do that, we come up with 1,066.2 calories. So a food item that contains 70 grams of fat contains a lot of calories. Let's take a look at number 4. We would do it the same way. 163.2 plus 12.9 multiplied by 10. And if we do that on a calculator, that comes out to be 292.2 calories. So we can see that if a food only contains 10 grams of fat, it contains far less calories. The last problem asks us to find and interpret the coefficient of determination. So remember, the coefficient of determination is r squared. It's literally your r value squared. Now the nice thing about StatCrunch is it computes it automatically. So let's go back to StatCrunch. And you can see it says r-sq, that's your r squared value. And you see it's 0.885. So let's go back and talk about what that means. So your r squared value is your coefficient of determination. In StatCrunch, it's abbreviated RSQ, so r squared. So that's how you see it in StatCrunch. And it was 0.885, and we usually write it as a percent because it helps us interpret it. So if we take 0.8585 and multiply it by 100%, we get 88.5%. And what this means, it's the percent of variation in y that can be explained by x. So again, if we think about our variables, so here this is calories. Oops, sorry, that's backwards. Here this is fat. And this is calories, right? So to interpret the coefficient of variation, what that means is that 88.5% of the variation we see in calories can be explained by the amount of fat contained in the item. So you can see that fat plays a large role in determining how many calories are in a fast food item. 88.5% of the variation in calories can be explained by how many grams of fat are contained in the food item. Only about 11.5% are due to other factors, but the vast majority of the variation in calories is due to how much fat is contained in the item. So that's it for this week's problem set.